We mentioned that earlier LSTM could solve certain problems in the long term dependency and so on. Still, you can't have a very large sequence for you to really do the back propagation. So, for the convenience, what we do is instead of having a 500 time slice, we actually create chunks. Okay, let us say if you have about 500 samples in the time state that you want to process, we can split it into 50 sequences of 100 samples each. Okay, and then every chunk you do the forward pass, back propagation, make the correction, and then go to the next chunk. And then when you go to the next chunk, take the hidden state of the previous state, feed it into this as your first input, and so on, right. So, the input from the previous chunk is fed to the current chunk, and you keep doing it until you finish all the chunks that you have created. Okay, so, this is called truncated back propagation through time. Okay. All right. So, this is how it looks. For example, this is my sequence that I want to compute, right. So, for example, I have a long sentence. So, instead of doing the back propagation or forward pass to all the states and then do the back propagation, I take a small chunk, do the error calculation, do the back propagation within this chunk initially, and then once it is computed, feed the value back to the next chunk here as the input. So, the hidden values, the previous hidden state of the previous chunk is fed as the input to the next chunk here. Okay. Do the computation for that chunk and then move on to the next chunk here and then do it. Okay, so, this is one way of doing the back propagation. This is called truncated back propagation through time. Okay, let us take one small example of how to really generate an English statement, given a corpus. So, in this case what I have done is I have taken a corpus that consists of 270 plus problems in kinematics, and then I have divided this into 100 characters per sequence, like I had shown earlier, right. So, this sequence is my chunk now. So, every sequence contains about 100 characters. The neural net knows nothing about this. All it knows is it contains characters like alphabets, punctuation, numbers, and so on. It does not know the word, it does not know the spelling of any of those, it does not understand any of those initially. All it knows is there are so many characters and it has to process each character one at a time, and then it knows that what is the next character to be predicted. So, in this case what happens is, suppose if you want to process this, right, I am just taking one example here, this is my input. So, my target would be like this, it will start with so, the first character would be k and it has to predict I. Then I should predict n, n should predict e, and so on. Okay. So, this is how the characters are fed. So, in this case I have taken all the problems, concatenated them into one single file, and it is a sequence of characters. So, from this I want to see whether the system is able to really generate a useful statement, okay, or a useful problem statement. This is the idea. Okay. So, it is a very difficult problem to solve right now. Okay. So, and also I do not have a very large corpus, I have only about 270 plus and consists of about 270,000 characters. max, it is very small in size. Okay. Here I am just inputting some problems of this type. A ball is thrown upward from a bridge with an initial velocity of 5.9 meters per second. It strikes the water after 2 seconds. If g equal to 9.8 meters per second square, what is the height of the bridge? So, I have problems of this type and 270 of them. I want the machine to read these problems and then try to predict what could be the next character, try to predict when is the ending of a word, and then finally construct a sentence for me. Okay. So, this is the goal of that. I have one RNN. This is what I feed, okay, and then I feed about 100 characters per sequence. So, here what happens is, so every time when it reads, it starts reading from the first character. Let us say this is up to 1 to 100. It will read 100 characters, and then for every character it will predict the next one. Okay. So, since it knows what the input is, it knows what is the gold standard that it should look at. Okay. So, you get this here. So, every time when it predicts, there is an error that happens. So, it starts correcting it as and when it finishes one sequence, and then at the end of some epochs. So, it says that okay, is enough, I have learned this, then it will use the hidden layer state as the input to the next sequence here and then go. So, it does not know, as I mentioned earlier, any word, the numerals or nothing, it all knows that everything is a character and it is now going to construct the sentence for me. So, at the end of 5% of the training, I think I have got 2000 epochs. So, every 100 epochs I output some value. Okay, so, this you can really change. So, at the end of 5% of the training, after it has seen the entire sequence, so it is able to construct words, and also you see that spaces, right. It is able to really predict what could be the next character after E. So, it has clearly found out the word, and then see hid, acceleration, and here tasking, it does not learn cleanly what it is. Okay, it is based on what is the predicted value, it tries to construct a word. Okay. And then here too. So, it is really funny to look at the sentence when it is really doing the training. Okay. At the end of 25%, you can see some reasonable words coming out. Since I truncate it at the end of 100 characters or 150, it does not show everything up. Okay. So, this is only during the training process I keep getting some values. At the end of the training, you now say that okay, give me a sentence starting with determine. Okay, it starts with determine the time it takes a piece of glass to hit the ground. Okay, so, probably it has seen somewhere that either the ground ended with a question mark several times. So, the pattern has been captured and then it ends with a question. Okay. And then a car drives straight off the edge of the cliff, of a cliff. So, it is interesting there too. Okay. So, this is the recall. You can see that there are not many spelling mistakes, even though the sentence is not semantically right. Okay, you can see it is trying to really create a sentence which are syntactically right. Okay, so, I am really baffled by the question mark also it adds at the end, So, with RNN, this is the possibility. You can do all of these with RNN. So, in this case I have used about 1500, not 2000, and then I have the hidden units as 75, and then I have 2 layers there. Okay. So, I have, when you unwrap, there is one layer and there is one more on top of it, and they are all connected like this and also vertically up. Okay. And then I used the learning parameter as 0.01 and my chunk size is about 150. This is what I had done. Okay, so, this is one example. Okay. So, this is a very simple example through which I had shown that it is possible for you to really construct a sequence of characters which makes some sense, okay, using RNN.